Using the digital twin of the assembly line, we are able to validate the production process and ensure that there are no safety risks with both the automated and manual assembly operations. First, we will validate the process to install the wing. Within the digital twin of the manufacturing process, we have the ability to jog and pivot the crane along its various axes. This allows us to verify the crane's movements faster than the physical world. Taking it one step further, we can turn on the collision test to verify the crane is able to maneuver the wing into position without making contact with any other structures. With the collision detection activated, we once again jog the crane along its axis. Notice when the two parts or tools collide, they turn red to alert you to an issue. With collision detection still active to safely validate there are no incidents or collisions, doing this virtually rather than in the real world will save both time and money. Let's move on and validate the manual assembly operations in this process using tools designed to evaluate human ergonomics and reproduce potential safety hazards. For this example, we will switch the final positioning of the wing from an automated delivery system to a manual process. First, we will verify the carry position for one of the employees, Jack, falls in an acceptable range. Note his hands fall in the green zone. This shows us his range of motion is an ergonomically safe area. For our next employee, Jill, we want to verify she has a sufficient line of sight to the airplane to complete her tasks. We will activate the vision window and direct her viewpoint toward the intended destination. As with the automated portion of the simulation, our goal is to eliminate any potential hazards before committing to the final assembly process. Finally, let's jump over to landing gear assembly area. Here, the operator is required to pick up a wheel and install it into a finished assembly. There are many ergonomic analysis tools available, but for this activity, we will focus on the lower back and study any projected strain identified here. Ergonomic reports allow us to review and save the amount of strain placed on the employee over the duration of the assembly process. Using national health and safety standards, the results are specifically calculated based on a worker's estimated stature. In this case, a female in the 50th percentile for both height and weight. Before we review the results, let's create the same report for another person. The ability to easily compare ergonomic results of the same task completed by employees of different physical builds can help us identify and hire the proper employee for the job. For this one, swap out our female employee in the 50th percentile to a male ranked at the 95th percentile. Once done, rerun the simulation. After generating a second ergonomic report, we can compare how employees of different physical builds are potentially affected by ergonomic strain. The results may often detect unforeseen consequences of various assembly tasks, such as how a taller employee may have an advantage when needing to reach a higher location, but suffer increased strain when bending over to pick up an object. The testing process may be repeated for multiple combinations of body statures and physical tasks. Now we have successfully validated the automated and manual assembly process to minimize safety issues and rework in the future.